In this lecture, let us see how to determine the center of gravity of compound sections. We very well know that if a section is made up of more than one simple sections, say if it consists two rectangular sections or one rectangle and triangle or one rectangle, two triangles, likewise if it consists more than one simple section, then it is a compound section. So here let us see how to find the center of gravity of an angle section. We can call this as L section or an angle section. So this is the vertical leg and this is the horizontal leg. The dimensions, say the vertical leg has dimension of 200 mm height, 20 mm is the thickness or width. The horizontal leg has 150 mm length, 20 mm depth or thickness. Okay. So first we should see whether the section is symmetric or unsymmetric with respect to x-axis and y-y axis. So for that, a simple rule will be, say if the section is divided into two equal halves by any axis, say x or y axis, if x-axis cuts the compound section into symmetrically two parts, two equal halves, or if the y-axis cuts the compound section into symmetrical halves, two equal halves or symmetrical sections, then we call this symmetrical sections. But here if you see in case of angle section, the compound section is unsymmetrical with respect to both x-axis as well y-y axis. So the y-y axis and x-axis axis need to be located. So let the y-axis be located at a distance of x bar from the left, and let the x-axis be located at a distance of y bar from the bottom. So to find x bar, say x bar means the distance of the y-axis from any reference axis. So for that we need to choose a reference axis. So let the reference axis for locating y-axis, that is x bar, be chosen at the left side as shown in figure. So you can see in the figure, say we have chosen a reference axis for x bar and it is optional. Either you can choose the reference axis either at the left or at the right. So in this problem we have chosen at the left. And divide the compound section into two simpler elements. Say this is divided into a rectangular element 1 and element 2. So we can either divide you can divide in the other way also, that is optional. So we have divided here in this order, in this manner. So as soon as we divide, to mark the clear dimensions of individual elements, say the height of element 1 is 200 mm and the thickness is 20 mm. In case if we divide it the other way, then the height would be 200 minus 20 mm. So that is if I have divided here like this, horizontally like this, then other way. Now as per this division, I have made a division like this. This is the dotted line showing the division. So the dimensions of element 1 need to be clearly marked before proceeding further. Similarly, the dimension of the horizontal section, say this will be, actually we had 150 mm total width. Now, since we have divided like this, 150 minus 20, that is 130 mm will be the clear dimension of element 2. Similarly, 20 mm is the thickness or height of the element 2. In case if we divide it the other way, say if I have made the dotted line here, then the width will be having the overall width, say 150 mm, and the depth will be 20 mm. So we should be able to do it either way, that is optional. And the x bar is given by a1 x1 plus a2 x2 divided by a1 plus a2. a1 is area of element 1. So area of element 1 will be width b into d. So b is 20 mm, d is 200 mm. So 20 into 200, 4000 millimeters square. And x1 is horizontal distance between the reference axis for x bar and the CG of element 1. So always all these x distances refers to horizontal distance. You can remember in that way. So horizontal distance. So here it has been marked. So x1 is the horizontal distance from the reference axis for x bar to the CG of element 1. So element 1 CG is here. So this distance is x1 as marked here. So x1 will be equal to this 20 divided by 2. It is clear from this diagram. x1 will be 20 divided by 2. Therefore 10 mm. Then A2, area of this element 2 will be, we have clear dimension 130 mm, 20 mm. So 130 into 20 will be the area. And x2, the definition is x2 is the horizontal distance from the reference axis for x bar, from the reference axis for x bar to the CG of element 2. So here, to find that, first we should find the distance which is available clearly from the reference axis. Say here clear distance we have 20 mm, and from this 130 mm, the CG will be at 130 divided by 2. Therefore, 130 divided by 2 will be the distance from here to here. And here we have clear distance of 20 mm. So that 20 plus 130 divided by 2 will be the x2 distance. Okay, is it clear? So the x distance, the definition is the horizontal distance from the reference axis for x bar to the CG of element 1. Similarly, x2 is horizontal distance from the reference axis for x bar to the CG of element 2. So this we should be able to find clearly, without any confusion. Then if you have found a1, a2, x1, x2, then x bar equal to a1, x1 plus a2, x2 by a1 plus a2. Therefore, x bar equal to 39.55 mm from the left side of the compound section. This is more important. This we need to mention because the x bar can also be the distance from the right side. But since we have chosen the reference axis from the left side, we need to specify it clearly. Now we'll go to find y bar. So for this y bar, we need to choose a reference either at the bottom of the section or at the top of the section to locate y bar, okay, or to find y bar. So here in this problem, we have chosen the reference axis for locating x-axis at the bottom. So all the distance we need to find from the bottom only. So here again, y bar, the formula is given by a1 y1 plus a2 y2 divided by a1 plus a2. So a1 is area of element 1, we have already found. So 20 into 200 will be the area. And y1, here the definition is y1 is the vertical distance. All y, say y bar, y1, y2, everything, y refers to vertical distances. So y1 is the vertical distance from the reference axis for y bar. This is the reference axis for y bar to the CG of element 1. So from here to here, we can mark, we need to mark in the diagram. So this will be y1. So y1 will be equal to total height we have 200. So 200 divided by 2 will be y1. Then y2. So y2 again apply the definition. That is, it is the vertical distance from the reference axis for y bar to the CG of element 2. So here the distance marked here. So y2 is from the reference axis for y bar to the CG of element 2. Vertical distance, that is more important. All y refers to vertical distance. So this will be 20 divided by 2. y2 will be 20 divided by 210 mm. Therefore, we can find the y bar as, say, 64.55 mm from the bottom. So this is more important. So this is how we need to locate the centroid of sections.